Welcome to Educate 247. Today we are going to see concept 7 of CAT Concept Express series. In this I am going to take a very important concept of Sudoku puzzle which is often seen in CAT examination. Alright, so that is why the name of the video being DILR Decoded Sudoku Puzzle. Alright, this is the easiest form of DILR that comes in CAT examination, and I think aspirants should be well aware about this upfront. Alright, rather than coming to know about this concept at the very end and then practicing for only 15 odd days or 1 month, I wanted you guys to be aware about it right now only and safeguard your 4 questions and 12 marks in CAT. Alright, so let's get started with DILR Decoded Sudoku Puzzle. So what is this Sudoku puzzle? Sudoku is one of the most popular puzzle games of all time. Alright, the goal of Sudoku is to fill a 9x9 grid with numbers so that each row and column and a 3x3 section contains all the digits between 1 and 9. As a logic puzzle, Sudoku is also an excellent brain game. If you play Sudoku daily, you will soon start to see improvements in your concentration and overall brain power. Alright, so basically, it's not necessary that it should only be a 9x9 grid, okay? But if suppose it is a 3x3 grid, this is exactly what a 3x3 grid looks. So if I place 5 over here, so in a way I am telling you that this 5 will not come over here, not come over here, not come over here, not come over here. Alright, so all the digits over here will be different. Alright, and in this way you have to fill all 1 to 9 digits over here in this grid. Alright, so this is the most basic explanation of Sudoku puzzle. How to solve Sudoku puzzles? So the goal of Sudoku puzzle is to fill a 9x9 grid with digits so that each column, row and a 3x3 section contains the number between 1 to 9, as I have already told you. At the beginning of the game, the 9x9 grid will have some of the squares filled in. Alright, your job is to use the logic to fill in the missing digits. So they will already give you some of the digits filled in the Sudoku puzzle, and then you have to arrange the others. Alright, with the rules that I have told you. Don't forget, move is incorrect if any row contains more than one of the same number from 1 to 9. Any column contains more than one of the same number from 1 to 9. Any 3x3 grid contains more than one of the same number from 1 to 9. Alright, I hope you have understood these rules. So what I'm going to do is I'm going to take a CAT 2018 slot 1 question which was completely based on this Sudoku logic only, if not anything. Alright, but what I want you to do is I want you to practice this Sudoku puzzle. You can go to the website sudoku.com, alright, www.sudoku.com, and practice some of the Sudoku puzzles. Even if you practice one Sudoku puzzle per day, trust me, you'll be a pro at it within 15 to 20 days. And this will help you a lot to improve your concentration as well as solving power. Alright, so let's get started with this CAT 2018 slot 1 question which was based on Sudoku puzzles. So let us read the problem statement that was given. You are given a n by n square matrix to be filled with numerals so that no two adjacent cells have the same numeral. Two cells are called adjacent if they touch each other horizontally, vertically or diagonally. So a cell in one of the 4 corners has 3 cells adjacent to it, and a cell in the first or the last row of the column which is not in the corner has 5 cells adjacent to it. Any other cell has 8 cells adjacent to it. Alright, so this is a general description about this n by n square matrix that they have given. Alright, so only this much information has been given. Straight we'll have to move on to the question to solve this specific problem set. So let us have a look at the first question. What is the minimum number of different numerals needed to fill a 3x3 square matrix? Alright, so here you do not need to literally apply Sudoku puzzle rules. This has been improvised. That is, you can repeat the numerals over here. Right? So we saw the rules for creating a n by n square matrix. So let's suppose this is a square matrix. Alright, 3x3. So again, it would be like this. So what happens over here is number of different numerals. Alright, so suppose we fill in A over here, alright, and B over here. Okay, so here it will be C and D because you cannot have numericals around this A to be the same, which might be diagonally or below it or besides it. When the cells above each other should not be the same. Alright, so I hope you have understood the conditions that with which we have to solve this question. So the best way to solve such a question is to begin with a numerical on the 4 corners because it is not going to violate any rule. So let's suppose I take 1 over here. So 1, 1, 1. Right, this is sorted. Now we have to deal with only 1 2 3 4 and 5 boxes. Now we need to understand one thing. Whatever comes over here will be unique, alright? It cannot be repeated because all the cells are adjacent to it, right? So let's suppose we take 6 over here, alright, and we take 2 over here. So this 2 comes over here, alright. It can come over here because no condition is still violated. This is not adjacent nor diagonally in connection with 2. Similarly, if let's suppose I take 3 over here, this 3 can come over here also. So we have utilized how many numericals? 1 2 3 and 4. So we have utilized only 4 types of numericals. Numericals you can take any from 0 to 9. I have taken this for simplicity, alright. This is just for showing. So with the help of minimum 4 numericals, we can solve this 3 by 3 square matrix with the rules that were given to us, and 4 is your correct answer. So the second question is of the similar type, only the n by n has changed over here. What is the minimum number of different numerals needed to fill a 5 by 5 square matrix? So instead of 3 by 3, now we have 5 by 5. So we have 5 rows and 5 columns. All right. So again, we have a knowledge from our 3 by 3 matrix that we solved. We can place one numerical at a distance of 3 by 3, right? Like if I place 1 over here, this one will come over here, this can come over here, this can come over here, and still it is not violating any condition because none of it is adjacent to each other. Alright. Similarly, if I take 2 over here, so this 2 can come over here, this 2 can come over here, right? And this 2 can also come over here, here. It can be repeated and it is still not violating any condition. Alright. Similarly, if I take 3 over here, this 3 can come over here, it can come over here, and here, right? So we have used 3 numericals till now and we have still not violated any condition. Now we can take 4 over here and this 4 can come over here, and here, and still it has not violated any condition. None of the cells are adjacent to each other which are same with filled with same numerical, right? So all in all, how many numericals we have utilized to fill a 5 by 5 matrix, and being minimum 4. Alright, so even the correct answer to this question is 4. So let us read this question. Suppose you are allowed to make one mistake. That is, one pair of adjacent cells can have the same numeral. What is the minimum number of different numerals required to fill a 5 by 5 matrix? So this was what we got, filling of a minimum 5 by 5 matrix from the previous question, right? Correct. We needed basically a minimum of 4 numericals to fill without making any mistake. But let's suppose I commit a mistake. All right. Instead of getting this, let's suppose here instead of this 1, I write over here 2. So what happens is I have committed one mistake because I have placed the same numerical adjacent to that cell, right? But still all other remains the same and still do not violate the condition as per the question. Hence, the minimum numeric numbers with different numerals required to fill a 5 by 5 matrix is 4 only. The correct answer is option number A. So this was a tricky question. This was just been formulated to fox you. But if you would have done this by this trial and error method, you would have got the answer easily. So the next question being, suppose that all cells adjacent to any particular cell must have different numerals. What is the minimum number of different numerals needed to fill a 5 by 5 matrix? This should be the most easiest question of this set, because so let's suppose this is a 5 by 5 matrix, right? Now all the cells adjacent to a particular number should be different. So if suppose I place 0 over here, so we can have all of the cells around this as 1 2 3 4 5 6 7 8, right? And you can again repeat it like 1 2 3, and then you can have 7 6 5 over here, right? Similarly, you can have 2 0 6 over here, right? Again you can have 2 and 0 over here, right? Again you can have 3 4 over here, then 5 3, then again 5 over here, and you can see none of the condition is not satisfied according to the given condition over here, right? So how many different numericals you need over here? These are the ones: 1 2 3 4 5 6 7 8 and 9. So the correct answer to this question is 9, which is option number A. So that's it in this video. Thank you and happy learning.